Hi, everyone, and welcome to Module 6, Lesson 1, our first lesson in the module on stoichiometry. So, reaction stoichiometry involves the mass relationship between reactants and products in a chemical reaction. This is the chemistry, the mass behind chemistry. We can do calculations. If I tell you how much reactant to start with, you can do a calculation to tell me how much product you should make. Or if you are given this much product, you can do a calculation backwards to determine how much reactant you started with. You're also able to do a calculation to determine how well your reaction proceeded and what your yield is. And so there's lots of different mathematical things that we're going to do with stoichiometry. So the mole is the heart and soul of stoichiometry, and it is defined as the amount of substance that contains as many elementary entities, so atoms, molecules, particles, formula units, as there are atoms in 12 grams of carbon. And Avogadro's number is 6.02 times 10 to the 23rd. That's how many atoms in 12 grams of carbon. And carbon is used as the base here. I'm not going to go into the details or the reasoning, and I'm not going to elaborate on what a mole is, because for some of you, it will just confuse you. We just want to think of it as like an all-being. Okay, so the mole is how much stuff is basically in 12 grams of carbon. And we'll talk more about this as we go through. So we are going to look at some mole conversions, and we're going to use this mole map. So you're definitely going to want to write this out. It's going to be very helpful to you. And what we're going to do is we're going to start this lesson, which is mole conversions, from the mole to 3 different things. So like I said, the mole is the heart and soul of stoichiometry. And we can go from the mole to either mass, which would be in grams. We can go to volume, which would be in liters. And we can go to those entities, which were atoms, particles, molecules, right over here, formula units. Okay, now how do I convert from moles to mass and mass to moles? Simple, we just need to look at our molar mass, which comes from the periodic table. We've done molar mass in an earlier unit, so that should be nothing special. Of course, we're going to go through all 3 of these. To go from moles to volume, it's important to note that 1 mole is equal to 22.4 liters, and there's a caveat here, of a gas at STP. Okay, so it can only be for gases. We can go from moles to volume, volume to moles of gases at STP. Well, what is STP? STP stands for standard temperature and pressure, which is going to be 0 degrees Celsius and 1 atmosphere. And I know we haven't talked much about pressure. We will in the future, but atmosphere is a unit of pressure, and 1 atmosphere is like baseline at sea level. And then to go from moles to any of these 4 things here, it's Avogadro's number. So 1 mole is equal to 6.02 times 10 to the 23rd atoms, molecules, particles, or formula units. Let me just tell you the abbreviations for these things so that they can help you, and if you see them, you understand them. There's really no abbreviation for atoms because it's 4 or 5 letters. Particles, you can just do part, P-A-R-T. Molecules, M-O-L apostrophe-C as molecules, and for formula units, big ol' F-U. Okay, so pause this and write this down. You're going to need this, and you're going to probably want to do it on a separate sheet of paper so that you can always have it with you in front of you while you're working. It's going to be very important. So let's use our mole map and do some conversions. We're going to do some different conversions with those different conversion factors. So let's see, what is the mass of 0.045 moles of carbon? So the first thing we want to do is look at the molar mass for carbon. This one's easy. I'm just going to do this for a couple of them so you can see. You just go over to your periodic table. Carbon, we're just looking up carbon here. And remember, when we do this, I want 2 decimal places. So we're going to do 12.01. And remember, that's grams per mole. So what that really looks like is 12.01 grams for every 1 mole. Because it's back dimensional analysis. If you didn't like it in the first module, maybe you like it more now, I don't know. But we still have to use it in order to do our conversions, because stoichiometry is conversions from one unit to the other, and we're going to be using our dimensional analysis with that. So remember, when you do dimensional analysis, you always start with what you're given. So I'm going to start with 0.045 moles of carbon, put it over 1. And then I know for every 1 mole of carbon, it's 12.01 grams of carbon, because that's what my molar mass is. So you see your moles of carbon cancel, you're left with grams of carbon. And the answer with the correct number of sig figs is 0.54 grams of carbon. Remember, however many sig figs we start with, we end with. So I started with 2, I end with 2. There's my answer. Okay, little typo here. It says, what's the mass of 20 moles of carbon tetrafluoride? And then I write carbon tetrachloride. So we're going to just do fluoride again. So first thing is, we need to do the molar mass, but we need to know what the formula is. So CF4. So we take the mass of carbon, add that to 4 fluorines, which is 19.00, and gives me 88.01 grams per mole. If you don't remember how to do molar mass, just go back to the previous module where we did it. I think it was module 2, and you can get a refresher on how to do molar mass. Okay, so I've got my molar mass there. Again, I'm going to start with what I'm given, 20 moles of CF4. And I really want to make sure that I'm including the thing I'm talking about. So I'm talking about CF4. So I'm going to make sure I include CF4 in there, my problem. And then I'm going to do, okay, I got 1 mole of CF4, and CF4 goes on the bottom, so it can cancel out with CF4 on the top. And then we do our 88.01 grams of CF4. And then we just get our final answer, which will be, with the correct number of sig figs, 2,000 grams of CF4. Okay, because 20 only has 1 sig fig. Next one, how many moles of calcium are in 525 grams of calcium? So I'm trying to turn grams into moles. So the molar mass for calcium, 40.06 grams per mole. Start with what I'm given, 525 grams of calcium. For every 1 mole now goes on the top, because I need to have grams of calcium on the bottom so that they can cancel. 525 divided by 40.06 gives me 13.1 moles of calcium. Start with 3 sig figs, end with 3 sig figs. Okay. If you have questions about the ins and outs of dimensional analysis, that was module 1, or you can type it in the chat or wait until the end of class, and I can always do more examples at the end. But in these notes, we're doing quite a bit of examples, so there should be plenty of examples for you to see. Okay, so the next one says, how many atoms are in 25 grams? Okay, so I'm going to clear this because I want to go, well, no, I'm not going to clear it because it's already gone. But if you look at your mole map that you made, if you start with grams, you have to go to the mole first, and then you can go to atoms. So this is going to be a 2-step problem, from grams to moles, moles to atoms. It's important to note, you always need to go, you can think of the mole as your base unit. From the mole, you can go to anything. Okay, so you always want to get into the mole first, and then from the mole, you can go to any of the other ones that you'd like. So the molar mass of gold is 196.97 grams per mole. So we're going to start with 25.0 grams of gold. Okay, we're going to put the 196.97 grams of gold on the bottom and 1 mole of gold on top. The grams cancel. I'm not done. I don't want moles. I want atoms. So I'm going to say, okay, well, 1 mole of gold gives me 6.02 times 10 to the 23rd atoms of gold. The moles cancel. And my final answer with the correct number of sig figs, which will be 3 based on the 25.0, is 7.65 times 10 to the 22nd atoms of gold. If you are still struggling with putting dimensional analysis in your calculator, please ask in class, because now I have like a calculator on my computer, a graphing calculator, and I can show you exactly what you should put into your calculator. So please ask if you're still struggling with that, and I can show everybody. Okay, so I'm going to clear this, go to the next page of examples. Okay, so this question is asking how many moles of gas are present in 100 liters of a gas at STP. Okay, so we're going from liters to moles, which is going to be one step. So again, I'm going to start with what I'm given, 100 liters. I know that there are 22.4 liters in 1 mole. So you're taking 100 divided by 22.4. I need 1 sig fig because 100 has 1 sig fig, and that will turn into 4 moles. Another question about volume. How many moles are in 13.5 liters of oxygen? Okay, so 13.5 liters of O2. We're going to put liters of oxygen on the bottom, moles of O2 on the top. Now, this question doesn't change just because I know what the compound is, because I'm still going from moles to liters, and that's always the same when we're at STP. 1 mole, 22.4 liters. You do the division, and you get 0.603 moles of oxygen. Okay, again, 3 sig figs, 3 sig figs. How many molecules is that? Okay, well, I'll start with my moles that I calculated from above. I know Avogadro's number, 1 mole of oxygen, 6.02 times 10 to the 23rd. Again, MOL apostrophe C, molecules of oxygen, gives me 3.63 times 10 to the 23rd molecules of O2. Now, I'm going through this fast. I'm going through it fast, and I'm immediately putting the answer down. If you need, please pause, put it in the calculator yourself. Do this yourself. Work through the process. Okay, like for the next one, if you want to see if you can do it yourself, pause now. Go ahead and try to work it out, and then you can play and see if you did it correctly. All right, so don't just feel like you have to run the video through. Make sure you're stopping, writing things down, doing this at your own pace. That's the glory of being able to pause and start this video. So 2 liters of CO2. How much does it weigh? Okay, so now I'm going to go to grams. So we can go from liters to moles. Remember, we always got to go to the mole first to grams. So 1 mole of CO2, 22.4 liters of CO2. The liters cancel. Moles of CO2 at the bottom to cancel out. I want grams of CO2. Well, I know 1 mole is 44.01 grams of carbon dioxide. Okay, you're left with what you want, grams of CO2. And do the calculation, 1 sig fig for my final answer. It ends up being 4 grams of CO2. Now, when we start out, this is going to be the longest problem, a 3-step problem. What you start with, 1 conversion, 2 conversions. Going forward, our longest conversions are going to have 4 steps, what you start with, and then 3 conversions. So that will be the longest type of problem you see for now. Next question, how many particles are found in 15 moles? There's redundant, of particles. So 15 moles over 1 moles to part. 1 mole, 6.02 times 10 to the 23. Again, look over this on your mole map that you drew out so that you can see the steps I'm taking, going from moles to particles, and you can see your conversion factor there. The answer with 266, 9.0 times 10 to the 23rd particles. And then the final one. How many moles of tin are found in 5.4123 times 10 to the 50 atoms? Okay, 5.4123 times 10 to the 50 ATOM. I know the mole has to go on top. Okay. Tin is SN, by the way. 6.02 times 10 to the 23rd atoms of tin. Do that math. It turns out to be 8.9905 times 10 to the 23rd moles. Okay. So again, most of this, it's just dimensional analysis using different conversion factors. So let's go. We've got just one more page here, and we're going to look at mole ratios. So mole ratios allow you to convert between the whole and a part. So it allows you to convert between the whole compound and elements within the compound. So for example, aluminum oxide. Aluminum oxide is Al2O3. A brief review of ionic nomenclature. Aluminum is +3, oxygen's -2. We go ahead and swap those, you get Al2O3. Now, a mole ratio is a conversion between moles and moles. So for example, in 1 mole of aluminum oxide, I can have 2 moles of aluminum, right? Because that's what the formula says, Al2. So there's 2 moles of aluminum in 1 mole of the compound. Or I could say 1 mole of aluminum oxide in 3 moles of oxygen. Okay, you get the idea. Magnesium phosphate. I could say a mole ratio would be for every 1 mole of magnesium phosphate, I could have 8 moles of oxygen, just based off of the balanced equation or the formula. So I can use those mole ratios to do a problem like this one. How many moles of aluminum atoms are present in 1.25 moles of aluminum oxide? Start with what you're given. Moles of aluminum oxide go on the bottom, and I want to go to moles of aluminum. So that would be this one right here. For every 1 mole of the compound, I have 2 moles of aluminum. So that answer is going to end up being 3.00. Wait, that's not right, is it? 1.25 times 2. Oh, what am I doing? All right, you caught a mistake. Me. 2.50. Oh, why I wrote 3. 2.50 moles of aluminum. Okay, so it says you can use ratios to determine the mass of elements in compounds. So how many grams of each element are present in 8 moles of potassium chromate? I'm going to do the first one for potassium. I'm going to have you do the other 2, and the answers are in the completed notes. So do them. It'll give you a good practice of doing a mole ratio and a conversion between moles in grams. So I'm going to start with 8.0 moles of potassium chromate. And then I'm trying to get to potassium. So for every 1 mole of the compound, I'm going to get 2 moles of potassium. So the moles of the potassium chromate cancel. And then I know we're going to put moles of potassium at the bottom, grams of potassium. And just from the molar mass, it's 39.1 grams for every 1 mole. Moles of potassium cancel. You're left with grams of potassium. Your answer with 2 sig figs is 630 grams of potassium. So I would like you to do the other two for chromium and oxygen. Works the same way, give you some practice. The answers are in the completed notes. And if you have any questions, please make sure you ask them in class, put them in the chat, or ask them at the end. And then I will see you back in class. Again, let me know if you have any problems.